Let's start working on question 3 now. So what do we have here? We have the quantity of a product is given by this variable Q and the price by P. We have the demand curve, which is given by 9 lambda square minus Q square. We have the supply curve, which is 2Q square plus 6 lambda square. Now in part A, we want to find the quantity for which demand equals supply. So this is a basic microeconomics questions. We're going to make these two equations equal. So we're going to have 9 lambda square minus Q square equals to 2 times Q square plus 6 lambda square. Now let's take the variables on one side, the quantities on the other side. So we have 9 lambda square. We take the 6 lambda square to the left. So we have 9 lambda square minus 6 lambda square. That becomes 3 lambda square equals to 2Q square. And we take this one to the right. So plus Q square is 3Q square. Now we can cancel out some stuff because this is an equation. 3 and 3 goes away. So we're left with lambda square equals to Q square. We're going to take the square root on both sides because we can do so. So we take the square roots, meaning that lambda is equal to the equilibrium quantity. Now with the equilibrium quantity in mind, we can substitute it into one of the prices. And let's say we're going to substitute into the price of the supplier because it's equal to the price of the demand as well. So it doesn't matter. What's that going to be? Well, the price is going to be equal to 2 times Q square, which is 2 times lambda to the power of 2 plus 6 times lambda square. So that's equal to 8 times lambda square. 8 times lambda square. So we found our part A. Now, what do we have in part B? Let's see. Compute the consumer surplus. Now, first of all, let's see what it means on a graph. The graph is going to be just a simple example. We're not going to make it accurately for this curve because it's not going to be a line for the demand and supply, but it's going to be a curve. We will still draw a line for the demand and the supply to understand the concept of consumer surplus and producer surplus with the integrals. What is the relationship between them? So let's say we have the price and quantity axis. We have the demand, and let's call that the demand curve like that. We have our supply curve as well, which would be something like that. We have an equilibrium price and quantity at the intersection. So this would be our equilibrium quantity and this is our equilibrium price. Now, what is our consumer surplus? Let's work with the consumer surplus in this video. Well, the consumer surplus we know is the area underneath the demand curve and the equilibrium price. So this is an area. What did we say about the areas? We can calculate them with the integrals. And what is the integral in this here? Well, it's an integral which is limited, is bounded by 0, right? It's from 0 until the equilibrium quantity. So from 0, and what is the equilibrium quantity? The equilibrium quantity is lambda. That's what we calculated. So from 0 to lambda. And what's going to be the function? The area under what function? It is the area under the demand function. So the demand function is given to us by 9 lambda square minus Q square. So we have 9 lambda square minus Q squared, right? The demand between the equilibrium price. So the area underneath the curve and the equilibrium price. So we have to subtract the equilibrium price as well, which is 8 lambda squared. Hope this makes sense. And we have to integrate all of this with respect to the quantity. Now, how do we do it? Well, let's see. First of all, we can work out this expression over here a bit because we have 9 lambda square minus 8 lambda square. That's just going to be lambda square. So we'll have a definite integral between 0 to lambda. 9 lambda square minus 8 lambda square is just going to be 1 lambda squared minus Q squared, the other term, dq. Now we can solve the integral. So we will have boundaries between 0 and lambda. So we'll have boundaries between 0 and lambda. What is the integral of lambda squared dq? Well, that's just going to be, let me just change colors. Lambda square is going to be lambda square times the quantity, right? Because lambda square is a constant. When we differentiate a constant times the quantity, what we get as a result is just going to be the constant. So it's going to be lambda square. Hope this makes sense. Now we also integrate the other term. We integrate Q square dq. What is that? Well, we're just going to use the power rule of integration, which is q to the power of 2 plus 1, which is 3, divided by 2 plus 1, which is again 3. Now with this in mind, we can start substituting. So we can substitute the lambda into this result. we can substitute the lambda into this result. The lambda goes into Q. Q is our variable of interest. So we will have lambda square times lambda. Let me just change colors to keep track a bit. So we have lambda square multiplied with lambda, and then minus, let's just go back to that, minus lambda to the power of 3 over 3. So we'll have lambda to the power of 3 over 3, lambda cubed over 3. Now, what do we have as a result over here? Lambda squared times lambda. This term is just going to be lambda to the power of 3 minus lambda cubed over 3, lambda cubed over 3. So we're subtracting lambda cubed, but we have different coefficients. This is a coefficient of 1 minus 1 over 3. What is 1 minus 1 over 3? That's just 2 over 3 multiplied with lambda to the power of 3. Lambda to the power of 3, and all of this is the area of the consumer surplus. So we calculated the consumer surplus with the integrals. In the next video, we'll calculate also the producer surplus.